Now that we've practiced working with the discriminant, let's go ahead and work with the entire quadratic formula. And so I've written it here again. You might want to do that too so that you can reference it as we go along. So the first thing that I want to do is confirm on example number 4 that I'm in standard form, and yes, I am. So I can identify A, B, and C. This time I'm going to go ahead and explicitly write them. A is equal to 1. B is equal to -7, and C is equal to -18. If you want to just write it above the equation like we did before, that's fine. So now we're going to plug into our quadratic formula. We're going to say that x is equal to -b, but b is already a -7, so don't forget that that's going to give us a double negative, which will end up being positive, so a negative -7 plus or minus the square root of b squared, and b is -7. Be sure you put your parentheses around the -7, minus 4 times a, which is 1, and times c, which is -18. Final part is to divide everything by 2 times a. So let's go ahead and do some simplification. I have a -7, so that can be written as a +7. And now I want to figure out what's under this square root, this discriminant. -7 squared is 49, and -4 times -18 is a +72. Remember that this is all still divided by 2 times a. 2 times 1 is 2. Let's continue. Now I want to go ahead and continue simplifying what's under the square root. 49 plus 72 is going to give me 121 divided by 2. Now I know that 121 is a perfect square. Okay, it's the perfect square of 11. If it hadn't been a perfect square, we would have dealt with that differently, but since it's a perfect square, I can say that x is equal to 7 plus or minus 11 over 2. So let's take that and break it into two pieces. X is equal to 7 plus 11 over 2, or x is equal to 7 minus 11 over 2. The first piece gives me that x is equal to 9. And the second one gives me that x is equal to -2. 7 minus 11 is -4. Divide by 2 is -2. Let's look at another example. In this example, the first thing I notice is that I need to move some things over in order to be able to work with this in standard form. So I am going to subtract 4w from both sides, and I'm going to add 1 to both sides. That's going to make those cancel here, and I will be left with w squared minus 4w plus 1 is equal to 0, and I can identify a as being the implied 1 in front of w squared, b is equal to -4, and c is equal to 1. So I am ready to plug into my quadratic formula. X is equal to -b, but in this case b is a -4, so I have a -4, plus or minus the square root of b squared, -4 squared. Again, remembering to put the parentheses around the entire -4 when you put that in your calculator, minus 4 times a, which is 1, and c, which is 1. Divide all of this by 2 times a, so 2 times 1. Let's continue working with this and simplify it. -4 is going to give me a +4. Plus or minus the square root of 16 minus 4. And that's going to be divided by 2. That means that x is equal to 4 plus or minus the square root of 12 divided by 2. And I notice that 12 is not a perfect square. What does that mean? Well, that means factor tree time. So I'm going to take 12 over here to the side and break it into 4 and 3. 3 is prime, so I'll circle it. 4 can be broken down more into 2 and 2, and now those are prime. And so I could rewrite this as the square root of 2 times 2 times 3, or the square root of 4 times 3. This is going to come out as I take the square root of 2 times 2, that's going to give me a 2 on the outside, multiplied by the square root of 3. So I can replace that in my quadratic formula equation. 4 plus or minus 2 times the square root of 3 divided by 2. And then finally, I can reduce my fraction because I notice that 2 will actually evenly divide into both pieces of the numerator. So that 2 that's in the denominator will divide into 4, leaving me with a 2. And then plus or minus 2 divided by 2 is just a 1. So I'm not going to write the 1, but I do still have that square root of 3. So my answer is that x is equal to 2 plus or minus the square root of 3. Of course, you could write that as two separate pieces, one that says 2 plus square root of 3 and another that says 2 minus the square root of 3. Why don't you try problem number 6 on your own and then come back to see how you did. Hey guys, a quick little correction here before we move on to problem number 6. Notice that the original problem had w's in it as our variable, and then I switched those to be x's. So in order to keep it consistent with what was in the problem, I'm going to change all of those x's to be w's. I'll let you choose whether you want to do that or not. In general, I'm not going to count a problem wrong if you accidentally write an x instead of a w. All right, so here's the corrected problem with all of the x's changed to be w's all the way down the line. Let's go ahead and look at problem number 6 now. And notice that I did use a z here because we have z's in our original problem. The first thing I notice is that I need to change this to be standard form by adding 4z squared and adding 3 to both sides. Writing my equation in standard form so that I can identify a is 4, b is -7, and c is 3. Then I plug into my quadratic formula. Again, remembering that I have a -7, so it's a -7, plugging in everything for the discriminant and all divided by 2a. 49 minus 48 gives me a 1, -7 gives me a +7, and 2 times 4 is 8. Let's break this into two pieces. I do notice that square root of 1 is a perfect square of 1. So I can say that z is either equal to 7 plus 1 over 8 or 7 minus 1 over 8. When I simplify this, I get z is equal to 1 here, and then I get z is equal to 6 over 8, which reduces to 3 over 4.